Alright, gentlemen, today's project is I'm working on the G0602, and I've been working on my recoil stock, and quite a few parts are CNC'd on the lathe, and this is my G0602 conversion that we've seen before, and I'm using what I'm now calling a hybrid machining. You know, I mean, we talk about hybrid woodworking where guys will use power tools and then hand tools. Well, I'm considering this CNC and still manual machining. And I've basically done it on the CNC mill for years once I converted it, because I can still manually switch it over and manually operate the table and the quill. So that works well for me. I'm still doing it. The G0602 is fully automated through the controller, but I still have spindle and coolant control and all the other controls just off of the keyboard. So there's a couple of things that I do on this that I've already discovered, and one of them is a part that I turn and thread, and then internally it has to be drilled and reamed, at least on one end. Now I programmed that in to run off of standard lathe tooling on the quick change tool post, but the steppers that I've got on this really don't have the power to hold position with it, so I haven't been real happy with that. That's probably an upgrade that'll happen, at least on the Z-axis, is we'll upgrade that stepper motor to something with a little more power and a little more holding power, so we don't lose positioning on it. I can do it, but the feed rates are exceptionally slow. I'm not happy with that for a production item. I don't care about things running slow on a 1 or a 2 off item, but when I'm going to do something consistently for production, well, I want them to operate it as fast as I can, basically. So the easiest way I found to do this is for my drill and ream operation on this one component, and there'll be other things too, is it's faster and easier and probably at this stage more accurate to run it off of the tailstock, just in a drill chuck. So that's what I've done on these. So one of the upgrades that I'm going to do is I'm going to add a caliper onto the quill of the tailstock. And as I've said before, I'm not a fan of Harbor Freight junk, but by the same token it does have its application. So this is the first one we're going to try, and this one I've already modified. This is one of their cheap, they call them a composite caliper. It's a piece of shit plastic caliper is what it is. It's all plastic. What we found over the years, and on all my Shumatech DROs, they use the inexpensive Chinese scales. It's what I've still got on the majority of mine, and I've got 3 of them running right now. So the Chinese scales are accurate. The thing that's bad about them is they tend to be rough, and the Harbor Freight stuff seems to be even rougher. When I picked this one up, and this is a $10 plastic item, so if it doesn't work for me, we're going to throw it in the trash and move on to another one. So this is a small investment, so it'll last until it doesn't, and the coolant gets to it, or it just quits working, whatever the case may be. I did pick up a 4-inch metal digital caliper, one of their Pittsburgh brands. There again, accuracy seems to be fine on it. It is exceptionally rough. I've already stoned the surfaces down, so it's better than it was, but it's still not as smooth as a nice Mitutoyo is that I'm used to using. So anyway, the way we're going to mount this is I'm going to mount it right here, about a 45-degree angle. This jaw will be in a bracket that mounts in here, and I haven't done anything with this bracket. And then the movable jaw, or the front jaw, will be attached to the quill itself with probably about a 3/8 thick collar with a bracket that comes out on it. And I've drawn that up in CAD. We're going to CNC that today. That's basically how we're going to mount it. What I'm going to do is I'm going to build this part, and I'll show you the drawings here in just a minute. And I've used a Chinese scale on the Sheldon lathe for years and years, and I like it. It's quick and easy, and a inexpensive, alternative to having a full digital readout, which you normally are not going to get on your quill anyway. So anyway, for my drawings, my paperwork, this is my initial sketch. This was my first sketch, run it up at a 45-degree angle. This will be our mounting surface here. I don't know if this is, then this is just my rough sketch. The second one, when I got to looking at the way that would be, I ran it straight out and ran a 45 degrees. So anyway, I've drawn this up in CAD. We're running Fusion 360. So these are my actual drawings here that I've come up with. This is what it'll be. This is our mounting surface up here for the movable jaw on the calipers. I've got it drawn as a 1/2 inch thick. What I've done is to set it up in the mill, I just got some scrap stock that I think is about 1 inch thick. We're going to go ahead, run our profiles, and once it's cut, we'll just flip it over and deck off the other side and get it to the thickness we want. It's not that important. We'll split it down here and put a locking bolt through. I didn't bother to draw that because it wasn't necessary. The only real critical dimensions is the 1.26 diameter, which I'm sure is metric conversion to something or other I didn't figure out, and then the distance from the center line of that out to where our mounting bracket's going to clear the tailstock itself. Everything else is kind of in the wind, you know, it's just to look halfway decent. I'm not going to worry about putting bevels on or anything. I'm going to throw it in the tumbler and we'll tumble off tool marks and smooth the edges before we mount it. So that's the drawing. From there we went to a setup sheet, again out of Fusion 360. I did this with 2 tools. What I did is we went in with a 1/4 inch drill and we drilled out the center of this just to relieve it, so when we ramp down in to cut the inside of that hole, we're not plunging into solid material. It's a little bit easier on it. The rest of it's done with a long 1/4 inch end mill, 2 flute, and we're going to run a 2D adaptive clearing around the outside and around the inside. Then we'll go back with the same tool and do 3 finish passes, 2 finish passes and a spring pass with a 2D contour around the outside to fix it. Once we get that done, we'll double check this dimension. Then we can pull it out of the mill, flip it over, and deck it off to probably 3/8 thick. So that's the plan. Machine time on this is exceptionally slow, and we'll just fast forward through parts of it. I'll let you see the highlights of it, and that's kind of what we're doing. So let me move this over so we've got some sort of a view of the mill, and I've already got a piece of stock in there that's been decked off. I've got the program loaded into Mach 3. That's probing just to pick up our X and our Y. And that's about where we want to be. I've already set my Z axis. Except you got to pay attention to what you're doing. I set this up with tool 13, which is what I'm profiling with. But I did a drill, 1/4 inch drill, just to clear that material in the center of the hole before we started. Since we've got them out, let's use these piece of crap Harbor Freight 4-inch calipers here. One 2.615, 1.265. I think that's close enough to where we're going to trust that dimension is going to be right, and we're going to fit it right there. So, we pull this out of the mill and blow it off. This is what we end up with. Just like that. So I'm going to go ahead, set it up, and we'll just deck off the back side of it. So we've got it down to close to where we want it. And see what it looks like on the machine. Alright, well, here's our part. As done as we're going to get it in the mill. I didn't worry about deburring anything. We'll have to break the edges once it's all fitted. I'm going to throw it back. I'm going to throw it into the tumbler, both the pieces, and tumble them to get rid of the tool marks and smooth the edges a little bit. And then we'll probably powder coat it, since we've gone to this much work on it. So anyway, let's take it back over to the lathe and see what it looks like. Alright, well, I don't know how close I can get you into seeing this right now without doing too many goofy things with the camera, but anyway, this is our piece. We're still a little bit tight on here. It doesn't want to slide right on. So what I'll do is I'll set it up and we're going to split it, because we're going to put a pinch screw, probably a 1032 socket head. We'll run right through there, right along there, and then we'll pinch it to go on there. I will bet once that's split, well, we've got enough to get that on there. Otherwise, we'll polish the inside just a little bit. It's right there. Been probably half a thou. But anyway, it will set on there. Just about like that. We'll drill it for our holes here, and we'll drill it here. So that will set on there just like that. We'll align it, of course, so that that can sit on there. That one, as I said, will be mounted right there, and as we advance it, it will lock it in place and give us our digital readout. So anyway, that's where I'm going to leave it for right now. I will probably go ahead and split it off camera and get it pretty well fitted up, and we'll see about what we're going to do for a block there. I'm going to get this fitted up so it goes on, and this, of course, retracts far enough that it will eject our tailstock, or whatever taper we've got in there, whether it be a chuck or a live or a dead center. I don't anticipate ever running a center on this. It will probably always be a drill chuck of some sort. But anyway, I'm pretty happy with that. Like I say, we'll split that, get it set up to drill and tap it. Once we get it split and set on there, why we'll get that part affixed in place. Then we can go ahead and do our final position on this and figure out what we're going to do for a block on there. And the block on there, realistically, will probably be quite simply a block at 45-degree angle, since this is where this is going to sit. That will sit there. We can mark that back side. We mark it right here. We can have the dimensions for our block that's going to sit there, because it's going to be a mirror image You know, the backs of these are flat right across there in that mounting area. So if we just have a block there and a block there, that's going to give us our proper position. So marking that there, we can take our dimensions off of that. If we build us a block of some configuration, this distance right there, we've got it. Anyway, hopefully you found this project a little bit interesting, and if you didn't have it already, you might want to hit that subscribe button. If you hit the bell notification, you'll know when I put out a new video. And any comments or suggestions, please leave them in the comment section for me below. And as always, thanks for taking the time to watch.